And welcome back to NASA Edge, here with the MMS team for round 2. We had to get rid of the first 9 and we brought in another 7. How you guys doing?
Good, great.
You said you were going to do much better than the first group, right?
Of course.
Okay, there you go. Okay. And that's a good place to start with Joanne. We had a chance to interview you, I don't know, about a year ago or so, or?
Yeah.
A lot's happened since then.
Yes.
As a test engineer, what have you done in the past year?
Well, in the last year, we have finished building 4 spacecraft. We've taken them through lots of different types of tests. We've done vibration testing, we've done thermal vac testing, we've stacked all 4 of them, and we've shaken the stack to simulate the loads that we'll see during launch. And we've done lots and lots and lots of testing and integrated lots and lots and lots of instruments.
How long did it take you to actually stack this 4 spacecraft?
Well, honestly, it took us about 4 days to actually get through the actual stacking process because there's a lot, of prep work that we have to do. And then we also have to bag the spacecraft because the vibration cell that we put it in is not as clean as our clean rooms. So that took a long time. And then it took us about a month to actually run through the whole test.
Wow. Now Justin, you work with Joanne.
Yeah.
And we gotta settle this right at the beginning. How was her performance on her first NASA Edge show?
Top notch.
Top notch. See?
I trained them well.
So Justin, what is as a test engineer, you pretty much do the same things that Joanne is working on?
Not really. I work with the different various subsystems to write code using a language that NASA invented to create the test that we run during the various environmental testing.
So NASA invented, what kind of code is that? Is it basic or?
It's very similar to basic.
Is it? So is that a long process to develop that code and work with that code too?
Yeah, I mean, we make a lot of changes to it throughout the test as we learn, what doesn't work and what does work. So.
And what were some of the challenges that you had to face during that time?
We've had a couple different hardware failures that we've had to take the boxes back off the spacecraft and have the various pieces of hardware reworked. And we have had several software problems that we upgrade the software, so when we find bugs.
So really, just like any other mission, when you're building a satellite or you're building a spacecraft, you come up with these anomalies, these issues during, that's why you're engineers. You test, you break things, you rebuild them, and you come up with new parts. Oscar, a few months away, we have, March is coming up pretty close. Are you getting nervous yet?
Yeah, definitely getting nervous. We're doing a lot of mission rehearsal testing, trying to get the team ready for launch and commissioning phase now. And
you have an important task because you're involved with the guidance and navigation with the spacecraft. So if it goes off course, do we come to you?
Yeah, probably first come to me, and then I'll go to the subsystem experts depending on what caused the problem.
Okay.
If it's a propulsion system problem, we'll talk to the propulsion PDLs, PDL project design lead. If I got that right.
There's so many acronyms at NASA. How do you keep track of all of them?
I hear there's actually a website that talks about all the acronyms that NASA uses.
Oh, really?
That's what I've heard. Okay. I haven't actually seen it.
You should probably take a college course in that. And say,
Yes, that in itself. And then if it's a problem with the controller, that'll be the ACS system, the add to control system. If there's any problems, the navigation side of things where orbit determination, we'll work with either the navigator hardware team or the flight dynamics team.
And that must be really challenging having 4 identical, I should say in quotes identical, because you said they all have personalities.
Yes, they all do.
But 4 spacecraft in a tight flying formation throughout the whole mission. I'd seen it's really challenging from a guidance and navigation perspective.
It is. It's extremely challenging. The 4 spacecraft are in tetrahedron, where when we get towards what's known as a region of interest, that's where we have to maintain what we call quality factor, how well the tetrahedron is to that region of interest. And as we're approaching towards perigee in different parts of the orbit, the spacecraft actually get closer together and they'll pass each other in their orbits. So that's definitely one of the areas we're concerned about, is them getting too close together.
Is there going to be a certain point where during the mission where you may see a point of interest that didn't come up before, and then you'll have to expand that tetrahedron or reduce the size of it? You could do that on the fly if you had to.
We do that. So there are, I think, 3 different tetrahedron sizes that we look at, or scale sizes. 10 kilometers, I think, 25 kilometers, and there's maybe on 150 kilometers. And during the early part of the mission, the scientists are taking a look and seeing what scale size is the right size for them to measure these reconnection events. So once you get to the primary phase, then they'll choose the size.
Now, sitting to your left is Tony, and you're involved in configuration management for MMS. What does that entail?
Controlling all of the project documentation, putting it out for review, release, making it available to the team, and work orders, that sort of thing.
So you have the power of the pen, so you could actually change a little something here and there if you want, if you had to.
I don't go around talking about it.
So like with Oscar's performance plan, you can just change that from an A to an E if you had to, or an A to an F.
He gets an A.
Now that's a lot of work because you have. I mean, I can imagine the stacks of paperwork for a mission, especially MMS with 4 spacecraft.
Close to 6,000 work orders right now.
6,000 work orders?
But 5,414 are closed, so that's a good number.
So I have to say you're pretty good at numbers.
That's it. That's as far as I go, yeah.
Now I've got to ask this question, Bobby. Engine valve drive engineer. I mean, last time I looked at a college diploma, I didn't see an engine valve drive engineer on the. Usually it's aerospace, it's mechanical, electrical.
That's correct.
Did you make that up yourself?
Yeah. Well, I try to find lots of titles on the project and fill those needs.
Okay.
But I'm a mechanical engineer, but for the project, I'm the engine valve drive lead. So engine valve drive is basically what drives the spacecraft. So as Oscar mentioned earlier, ACS has their.
And what's ACS stand for?
Attitude control system.
Okay.
So they want to move the spacecraft, they do their software, and then they tell EVD to fire a thruster. And then we handle the actual firing of thrusters at their predetermined duration and sequence. So we handle the hardware portion of actually firing the thrusters. And we work in concert with the propulsion system as well. So it's a big effort as a unit. It's not just one single system.
Now, were you involved in actually determining that hydrogen was going to be used for the?
No.
So you're not part of that? Okay.
No, I'm not. That would probably be propulsion or stuff that I don't know about. That's a little out of my range.
I think it's fair to say Kenny doesn't have a cool name. He's just mechanical engineer, but you're engine valve drive.
I am the engine valve drive.
Which is pretty cool.
That's pretty cool. We shorten it. We call it EVD.
Okay, EVD?
And we're always go, so.
All right, Bobby, I don't know if you knew this, but you actually have an education and public outreach lead for the mission, and he's sitting to your right. That's Troy.
How you doing? Nice to meet you.
So Troy.
Thanks, Chris.
I'm going to say EPO lead and see if people know what that means, education and public outreach.
That's right.
You have actually a pretty cool job because
I do.
You have all the engineers working on the project, you have scientists working on the project, and sometimes and let's face it, I mean, this is just honesty, sometimes it's tough for the scientists to deliver that information in a very easy way to the public, and that's where you come in.
That's right. I like to think of myself as a translator. So I end up working with various people that I talk to in the mission, whether it's engineers, scientists, technicians, or even photographers in the various career fields, and end up having a conversation with them and with the Office of Communications folks, and we find out a little bit more about their story and then try to piece together how we can translate that into something classrooms, museums, general public can use, and that goes into a variety of projects that we work on.
Now, over the past several years, as you've been engaging the public, talking to them about the MMS spacecraft, I mean, you have some cool outreach materials from models to Lego models to the cutouts. How have the kids been inspired? I mean, because to me, when you look at 4 identical spacecraft, you see this in a tetrahedron pattern. I mean, there's a lot from an education standpoint you can teach these kids. I mean, what have you been doing to try to enhance that MMS mission?
Well, when I first came on board with the mission, they said one of your biggest challenges with this particular mission is the concept is very abstract for the public, and you need to work on ways with our team to find ways to help the public try to take that in a usable, digestible way that makes sense to them for how does this affect me here on Earth and why would I care? What I found out is when you go into classrooms and you talk to different groups, when you first say Magnetospheric Multiscale Mission, if you're not careful, you'll see eyes start to glaze over. So I immediately come in there and start talking about magnetic explosions in space and the trigger of space weather and how we're flying 4 spacecraft, almost like a jet formation around the Earth for 2 years. And when you start talking in those types of engineering terms and then mix the science in, eyes start to brighten up a little bit, people get very interested in it.
I like the analogy of a jet formation going around the Earth, and you can use this, it's free charge, but once you classify yourselves as the Blue Angels of NASA.
I think that's a great idea. I think that sounds great.
So Troy, in terms of education, public outreach, you have a sort of a counterpart, which is public affairs, and that's where Susan comes in. So Susan, while Troy's in the classrooms talking to informal educators, you're dealing with issues for the public.
Yes.
And what's that role as a public affairs person?
I basically take the science and the mission and I try to break it down like Troy does and make it digestible enough for reporters, news media. And reporters and news media these days don't do a specific beat, so you have to be able to explain things to them. What's difficult about this mission is the visuals. It's not like SDO, which has really pretty pictures of the sun, or other missions that have earth science missions that show hurricanes and wildfires. We have a team that works with us that actually do the visuals. We have a web person, we have a science writer, so we work together to get the story out.
When the 4 spacecraft are orbiting around the Earth, I mean, you're not really seeing magnetic reconnection, are you, with your naked eye?
No.
I mean, you're only getting it, in situ through your science instruments.
Right.
Based on a set of numbers and that data. And then when you bring that data back down, it's the scientist's job to decipher that and synthesize it, right? So I can see it in one sense. Yeah, it's kind of hard to get the public excited about seeing nothing.
Right.
But it's still pretty cool from the engineering aspect to be able to pull that off, to learn about magnetic reconnection, and do it in a way that's it's very challenging. I mean, that's got to be very rewarding for all of you.
It really is a challenge for us. That's why it's very important for us in education and communications to reach out and partner with other organizations that are very good, along with NASA, that we can work with to do outreach. For instance, the International Society of Technology and Education. They're just experts at helping us get to the public with great outreach materials that are cutting-edge education technology, such as 3D printing, for instance. We're starting to learn how to use that. We're also getting into real serious model building with hobbyists and groups and clubs, and we have one incredible model. All of those materials are going to be ready to download shortly.
Now, Joanne, so let's assume we have a successful launch in March. Atlas V goes up, the 4 spacecraft are deployed. You go through your 5-month test period, everything checks out, and then now you're into your mission. Just for the sake, let's say there's an anomaly on board one of the spacecraft. Does the team then come back together that worked on it and try to figure out what's going on and to come up with a solution to that problem?
Yes. So, during the mission, if there's a problem with one of the components, they'll definitely, they call up. Actually, Oscar gets called up a lot from his previous missions to help solve problems. So we definitely pull on everybody on the team who needs to, solve problems.
So Oscar, it seems like you have some experience with from past missions.
That's correct.
And can you share some of those examples?
So the past mission I've most recently been working on is LRO, the Lunar Reconnaissance Orbiter, and there's been different anomalies that have occurred where we've entered what we called sun safe. So I get called back in to help diagnose what happened, what caused us to enter those, and then to get us back into the observing mode or into science operations.
Very cool. And are there any stories that you can share from the past 3, 4, 5 years that maybe it was something in a lab that was pretty funny, something that happened where you had to really come up with a unique solution to solve? Was there anything that was challenging that you can think of that you'd care to share?
I'll pass to Joanne.
Let's see. Well, actually, we did have one of our transporters burn up one time. We were transporting one of our spacecraft to the Naval Research Lab for our thermal vac test, and we noticed there was smoke coming out from the truck. So the fire department was there, and we had some of our folks, get the fire extinguishers out. And luckily, our spacecraft was fine, but that was pretty exciting and kind of scary. But we did have to redesign our transporter pretty quickly so we could get, and we had to come up with different solutions so that we could, make sure that we were ready to take our spacecraft back and bring the other spacecraft back to NRL. So
what you're saying is Tony had probably another 1,000 pieces of paperwork she had to do for it to make that happen. But
yeah, so Michelle had a lot of work to do since she's the safety engineer. She had a lot of work to do.
Now, in considering something like that, I mean, from the public affairs side, I'm sure you had to be involved. I mean, that's anytime something happens where you have an anomaly or something that
That's
occurs.
a call I never want to get.
That's right.
And I did. Yeah, we work closely with the project team and the project managers and the leads, and then we work out. We make sure we have all our details straight and the information is correct, and we go ahead and release it to the public. But I mean, stuff like this does happen. It's just important to work together to make sure that the message is correct to get out.
And Justin, going back to you, as far as a test engineer, and you're working with software, is your job still functional as the spacecraft are orbiting around the Earth?
Yeah, I'm actually also part of the flight operations team that will be managing the flight of the spacecraft after launch.
Is that sort of a subset of the entire team that will stick around? Is it? I mean, in other words, does your entire MMS team become more of a skeleton crew during the actual mission, or are you still intact during that time?
A lot of our systems engineers and subsystem leads will definitely be there at the beginning. I think once as Justin is part of this flight operations team, there's a core team that actually flies the mission for the 2 years. And they work with the scientists and get the data down and put the spacecraft in the right orientations. So part of the team does continue on through the operations sections, and then a lot of the other people go on to different missions.
Now, Bobby, you said you talked about you're the engine valve drive. I love that EVD. That's really cool. Are you the only one at NASA that's an EVD?
Yeah, I think so.
I've never heard of that before.
They call it PDE and other things on other missions. So I think I could be the only EVD lead on NASA.
So you'd be part of that. I mean, you still stay on since
We'll stay for commissioning, and once we hand it over to the flight ops team, like you mentioned earlier, unless there's an anomaly, we won't be supporting. So we'll support through commissioning.
Wnow, where's who's going to be controlling the spacecraft once it's in orbit and collecting data? Is Goddard responsible for handling?
Justin.
So you're going to be sitting on console, throughout the day, making sure the spacecraft are healthy.
Yeah, I mean, for those 5 months of commissioning, it'll be running 24 hours a day. So
you're not going to be in there with the joystick and say, hey, I want to play some games and change the tetrahedral shape of this and see how things are going.
Yeah, it doesn't work like that.
Doesn't work like that? Now, how long, let's say you had to change the orientation of the spacecraft. I mean, how long does that take from the time you send it commands to when the spacecraft receives it and it starts to move?
From the time we send the commands, I'm trying to think of the right way to answer this question. So the commands we have is all on board, so we do it through an automated sequence. So once we enter the mode, it takes a few minutes. By the time that we've changed the size of the formation. We actually did a mission readiness test last week where we were changing the formation size, and the maneuvers were all in the order of a couple minutes.
Now, is there any point throughout the orbits where you'll lose contact with the spacecraft?
That we lose contact with the spacecraft? Actually, with our whole orbit, we actually have good view periods to all the stations. It's just what's available and how much contact time we need. So for our mission, normally we have per orbit, which is about a day for phase 1, we'll have 1 DSN pass plus 2 passes with TDRS, which is near perigee. So we'll have a pre-perigee and post-perigee TDRS passes. When we have maneuvers, we'll have an additional DSN pass.
And that's Deep Space Network?
Yeah, sorry, Deep Space Network. And I don't remember what TDRS stands for.
Tracking, right. And we covered TDRS, and I still don't. See, I got to take the course, with the website.
Exactly.
I do have a question that I want each of you to answer. And we'll start with you, Susan, and we'll just kind of go down the line. How has this mission impacted your life over the past several years?
Well, actually, all the heliophysics missions impact my life because I've learned so much about. I don't have a science background, so I've learned so much about the science, and what the Sun-Earth connection. And when you talk about what happens on the sun, it's 93 million miles away, but it can affect us here in our technology. So that's how it's impacted me.
Joanne?
So. For me, MMS for me has been a big exercise in logistics. So just trying to plan every day what we're doing has been quite an experience. And also, working with everybody has been great, and I've made a lot of new good friends.
Sounds like when you retire from NASA, you could probably become the president of UPS.
I'll think about that one, yeah.
Oscar, what about you?
So I think the biggest takeaway I've taken from working at MMS is, again, just the logistics of things for spacecraft, making sure that we update things as we test. One of the things we do when we build single spacecraft is you do procedures, you do tests, you do it one time. So you take those lessons learned, but you may or may not fold them in. Here we have to fold them in to make our lives easier as we continue on.
Tony?
What was the question again?
How has MMS, this mission, impacted your life since you've been working on the project?
I think that here at Goddard it has helped. I mean, I've learned to be, I think, more organized, and again with the 4 spacecraft and trying to keep things separate, and the way that we track data. We've actually gone. We talked about the fact that they were numbers 1, 2, 3, and 4. Each one is color coded. Also, I don't know if anybody said that, but within our database, we've actually made it so that, let's say you're entering a work order, depending upon what observatory you're choosing, it's actually coming up on your screen in that color. When we print your work order on paper, the same color paper.
Right.
So we've definitely overcome challenges, I think, from the very beginning.
So you're pretty much making life easier for the engineers and scientists
We hope so.
working on the mission.
We hope so.
Justin?
Well, this is actually my first mission out of college, so just learning the logistics of how it actually works and how spacecraft are really built. So.
Well, I'm going to stay with you for 1 second. So you're just fresh out of college. So do you think college has prepared you for the MMS mission?
Yeah, I would say they did a pretty good job.
Did a pretty good job? Okay. Troy?
I think the biggest takeaway for me is learning how to deal with very difficult people like Susan. I'm just saying, Susan, I just had to throw it out. No, we get on great. I work right beside her. I have to be careful. No, but actually, being able to work with the variety of people that I am exposed to in this mission has been incredible, because I get to take that and I get to see the expressions on people's faces when I tell them about a different type of career that they could actually follow and pursue. So for me, it's all about the passion of why people here do what they do and trying to figure out a way to convey that out to the public.
And the only engine valve driver at NASA.
What I take away is I was brought here to work MMS, so that's why I was brought here. So MMS has afforded me lots of opportunity to grow career-wise and with my peers. So it's I think the project as a whole has afforded lots of people lots of opportunity to work in other areas where they might not usually work, and see what's a good fit, and just really understand how Joanne handles INT. She does an excellent job doing it. It's a lot going on for all of us, and I think it's been a great opportunity, and I'm excited and thankful to be a part of it.
Well said, and I want to thank all of you for participating in this event. We're still looking forward to this launch come March, and seeing actually the MMS spacecraft perform, and actually seeing the first data come back down and see if you actually have magnetic reconnection.
It better be there.
Well, thank you again. Thank you so much for joining us in this special edition of NASA Edge. Our intent was to get a look at how a team functions together. Normally when we do our video podcasts, we're interviewing engineers and scientists one-on-one, but this is a first chance to get a group of people together, hear their responses, and see how they interact with each other. So thank you for watching NASA Edge, an inside and outside look at all things NASA.